Here are the operational taxonomic units that we are going to be analyzing and creating a phylogenetic tree for today. These are based off of differences on their phenotypes, whereas usually you would base it off of differences in their DNA sequences. It's important to note that we're basing it off of differences in their phenotypes, which is their physical appearance, and we're not basing it off of their function. These are all hair utensils or brushes of some sort. However, the ones on the right side are for humans, and the ones on the left side are for cats and dogs, and this one is actually an American Girl doll brush. So, let's get started. This is our phylogenetic tree. We are going to be filling it in from most recently diverged to everything that came before it. Our first operational taxonomic unit is this comb. It has a handle and metal bristles. The next one is most related to this comb. It also has a handle and metal bristles. This next operational taxonomic unit has a handle, but it has plastic bristles. So it is closely related, but not as closely related. This next one has plastic bristles, but no handle. So this one diverged earlier on. Next, we have our brushes that have plastic bristles. This is a brush that has plastic bristles, so it goes here. This one also has plastic bristles, and it is closely related to this one, so that goes here. Next, we have our brushes, but with metal bristles. So this one goes up at the top, here. This one is most closely related to this one, that also has metal bristles, so it goes next to it here. Now we have our outgroup. The outgroup is the operational taxonomic unit that diverged much earlier than the other ones. It does not share a common ancestor with the rest of the brushes and combs. Now that we have the order in which all these brushes and combs diverged, we can go into a little more explanation. Like I mentioned earlier, this is a rooted tree. A rooted tree shows us not only the distances between the operational taxonomic units, but also the order of divergence. This can be seen by each of the nodes. I filled in the nodes with A, B, C, D, E, F, and G. These nodes show where a split has happened. Node A is the location of the most recent common ancestor between the brushes and the combs, but note that it does not include the outgroup. The nodes represent where cladogenesis has occurred, which is the splitting of a lineage into different branches. Anagenesis occurs within one lineage over time. It does not create as much biological diversity as cladogenesis does.